Hello there, I am Abhijit Roy. Let us start today's lesson. Okay, have you ever heard of crackling sound while taking off your clothes? Yes? So these are the things that we are going to discuss in this unit called electrostatic. In 1600 BC, a Greek philosopher Thales discovered that amber, when being rubbed with wool, acquire a property of attracting small objects like piece of paper, dust particles and dry leaves, etc. There are many other substances which develop this property of attracting small pieces or small objects after being rubbed. Let us see a few examples. A glass rod on being rubbed with silk. Here you can see that I have underlined on being rubbed. Then I think you can relate this example with your daily life. A plastic comb on being run through dry hair. So if you rub a plastic comb in your dry hair, after that you can see that it develops a property to attract small pieces of paper. Here one need to keep in mind that because of rubbing or friction, the substance acquires the property to attract small objects. So now we will see what is frictional electricity. The property of rubbed substances due to which they attract light objects is called frictional electricity. Frictional electricity is also called static electricity. So why it is called static electricity? We know that static means at rest. Then why frictional electricity is also called static electricity? The reason is that the charge that develops on being rubbed or friction doesn't have the ability to move from one point of the body to another. That is why it is also called static electricity or electrostatics or electrostatics. Now we will see how scientists came to know that there are two kinds of electric charges. So if we place two ebonite rods, or if we suspend two ebonite rods rubbed with fur, both of them are ebonite rods and both of them are rubbed with fur, we will see that they are repelling each other. Similarly, if we take two glass rod, both of them being rubbed with silk cloth, they are also found to repel each other. What you need to understand is that here both of them are ebonite rod and both of them are rubbed with fur. So the charges that develops in these two rods should be of same nature. Here also both of them are glass rod and both of them are being rubbed with silk cloth. So the charge that develops in these two glass rods should be of same nature. That means the conclusion is that if we bring two charges of same nature very close to each other, they will repel each other. Now let us see what we have done. We have taken one ebonite rod being rubbed with fur and one glass rod being rubbed with silk cloth and placed close to each other. This time we have seen that they are attracting each other, which means, or the conclusion that we should get is that the nature of the charge in ebonite rod is different from the nature of the charge in glass rod. That means there are two types of charge. The charge which was developed in ebonite rod was called resinous, were earlier called resinous and now we call it negative charge, and the charge which was developed in glass rod were earlier called vitreous and now we call it positive charge. So we came to know that there are two kinds of electric charges. One of them is positive, another is negative. So now we can conclude that there are two kinds of electric charges. One is positive and another is of negative nature. And the next point is that like charges repel. That means if the two charges are of same nature, whether it is positive positive or negative negative, they will repel each other. and unlike charges attract each other. That means if the charges are of different nature, then they will attract each other. Now we will see what exactly electric charge is. It is a property of elementary particle electrons and protons which gives rise to electric force of attraction or repulsion between them or between various objects. The charge possessed by an electron is minus E and the charge possessed by a proton is plus E. What is E here? E doesn't stand for electron here. E is a constant whose value is 1.6 multiplied by 10 to the power minus 19 coulomb, and coulomb is the SI unit of charge, and you must know that charge is a scalar quantity. So now we will see three cases. Case number 1. So this is a body which has 5 protons and 5 electrons. Let us try to calculate the total charge in that body. 5 proton means 5 times plus E and 5 electrons means 5 times minus E. So clearly you can see the net charge becomes equals to 0. So this is a neutral body or neutrally charged body. Now let us take body B. It has 5 protons and 4 electrons. So let us consider that earlier it was having 5 electrons only, but during friction or during rubbing it loses one of its electrons. So now it has 4 electrons. So let us check. 5 plus E, charge of a proton is plus E and 5 protons, so its charge will be 5 times plus E. Then charge of 4 electrons, that means 4 times minus E, so it is 5E minus 4E, it is plus E. That means it is a positively charged body. It is a positively charged body. So the conclusion is that if number of protons present in a body is greater than the number of electrons, then the body will be a positively charged body. Now let us have a look here. It has 5 protons and 7 electrons. Earlier this body was having 5 protons and 5 electrons only, but during friction or rubbing it accepts or it gains 2 electrons from the other body. So now it has 7 electrons and 5 protons. Now let us try to calculate the total charge in it. It is 5 protons, that means 5 times plus E, and 7 electrons, that means 7 times minus E, that means 5E minus 7E. Now its charge is minus twice E. So we can clearly see that this body is a negatively charged body, or we can say that, or the conclusion is that if the number of electrons present in a body is greater than the number of proton it has, then it will be a negatively charged body. Or you can simply, altogether you can say that a body will be positive or negative charge if the number of electrons and the number of protons are not equal. So now we will see how does an object acquire charge while rubbing. So we have taken 2 bodies. Let us consider this as body A, whose total charge is 0. As we can see that there are 5 proton and 5 electron. Here we will denote proton by P and electron by E negative. So it has 5 proton and 5 electrons, so its net charge or total charge will be equals to 0. Similarly goes with charge with body B. It has 4 protons and 4 electrons, so its net charge or total charge will be again 0. Let us consider that rubbing is taking place between A and B, and let us assume that B needs less energy in comparison with A to donate electron. So while rubbing is taking place or friction is taking place between A and B, to overcome friction we will have to supply energy, and that energy is received by B to release its 2 electrons. So let us consider B has released 2 electrons. So now A has 5 protons and it has accepted 2 electrons which has been donated by B. So it is 5 electron plus 2 electron, and B had 4 protons. So it has already donated for 2 electrons, so now it is left with 2 electrons. Now its charge will be 5 proton. Charge of a proton is plus E, and clearly we can see it has 7 electron. Charge of an electron is minus E. So net charge becomes minus twice E. Now it has 4 protons, so 4 times plus E. It has 2 electron. It has already donated 2 electrons, so it is left out with 2 electron. Earlier it was having 4 electron. So 2 times minus E. So 4E minus twice E becomes twice E. So clearly you can see that the object which has donated 2 electrons, it becomes a charge of plus twice E. That means it acquires positive charge because of its large number or excess amount of protons, and the object which has received electron, it becomes an equally negative charge. Clearly you can see that the magnitude of charge of A is twice E and the magnitude of charge of B is twice E, but the nature is different. Its nature is negative because it has accepted electron, and its nature is positive because it has donated electrons. So this is how an object acquires positive or negative charge. Now you might wonder that whether it is possible to donate protons instead of electrons. Well, the answer is no. Let us see why it is not possible to donate protons. According to atomic model, an atom consists of a positive core called nucleus, which consists of protons and neutrons. An electron revolves around the nucleus. Now, the force of attraction between protons and neutrons is the strong nuclear force, and the force of attraction between nucleus and electron, or you can say the protons and electrons, is weaker, comparatively weaker electrostatic force. So it is possible to supply the energy to take out electron from an atom by rubbing or friction, but the energy that we supply or that it acquires while rubbing or friction is not enough to take out protons from the nucleus. So it is not possible to donate protons or to accept protons. It is only possible to donate electrons or accept electrons by friction or rubbing. We know that charge is a property of electrons. So if an electron moves from one point to another, then its property, that is charge, will also move from one point to another. Now let us see the difference between conductor and insulators. Conductor has a lot of free electrons. That means the electrons which are not bound to the nucleus or which are not confined in the atom. So if those electrons move from one point to another, that means they are carrying their charges, which is their property, from one point to another. That means it allows flow of charges. In case of insulators, it doesn't have any free electrons. All the electrons that an insulator have are bound to the nucleus. They are not free. So if the electrons are not free, they cannot take charge from one point to another. So we can say that in case of insulator, a charge cannot flow from one point to another. Or we can say that it doesn't allow flow of charges. So now we will see a phenomenon called electrostatic induction. Here you can see a conductor which will have, obviously because it is a conductor, it will have a large number of free electrons which are negatively charged. Then what we have taken is a positively charged glass rod and we have kept it near its end A. Now we know that positive charge will attract electrons because they are negatively charged. So this positively charged glass rod will try to attract as maximum number of free electrons as possible. So this end becomes negative charge due to accumulation of free electrons. And why the free electrons came here? Because of the attractive pull due to the positively charged glass rod. And this end becomes positively charged due to deficiency of free electron. So this negatively charged appears due to excess of accumulation of free electrons, and this appears positive, or this end appears positive because of the deficiency of free electrons. Now this is an electrification which is called temporary electrification. Why? Because as soon as this positively charged glass rod will be taken away, there will be no attraction between this glass rod or between this positive charged glass rod and free electrons. So again free electrons will start moving randomly and the charge will disappear in this conductor. These charges which are induced here because they were not there earlier, so these charges are called induced charges, and the charge on the glass rod which induces these charges are called inducing charges and the phenomena is called electrostatic induction. Now let us see in brief what is earthing or grounding. In my upcoming lectures in current electricity, I will explain these things in detail. Let us see what is earthing or grounding of a charged body. Now, if a charged body is brought in contact with earth, that means if we take a wire and connect it to the charged body and with the earth, then what happens? Every charge that was there in the body disappears. How? Let us see here. So first of all, this is how we denote grounding of a charged body, like this. So let us consider this as a negatively charged body. The moment we have grounded it, so this was earlier a negatively charged body. So negatively charged body means the charges are due to excess of electrons. So what will happen? The moment you ground it, all the electrons will go to the ground or will go to the earth, and it will become a chargeless body, or it will become a neutral body. Similarly, if we take a positively charged body and connect it with the ground with the help of a wire, electron will come from the earth and it will neutralize the positive charge. So in both the cases, we have seen that the negatively charged and the positively charged, as soon as it is brought in contact with the earth with the help of a connecting wire, their charge disappears, or we can say that both the body becomes a neutral body. This process is called earthing or grounding of a charged body. Now we will see how a conductor can be negatively charged permanently by induction. So here are 4 steps. So in the first step, we brought a positively charged glass rod near the end of the conductor. So its near end becomes negative charge, how we know already, and its further end becomes positively charged. Now what we have done in the second step, we have connected one wire from this end to the earth. That means we have grounded this end, or we have earthed this end. So now what will happen? Electrons from the earth will come and neutralize this charge. So this is the result. Electrons from the earth came and neutralizes the positive charge. After that, we have disconnected the wire. Now in the fourth step, we will take away this positively charged glass rod. We will take away this positively charged glass rod, and as soon as it is taken away, this negative charge will spread uniformly throughout the conductor. So this is how we can charge a conductor negatively.